All right. Well, let's just get straight into it then. Welcome to the Atari Breakout Workshop. Today we'll be learning how to rebuild the classic Atari Breakout game in p5.js using Replit and a whole bunch of cool tools, and no downloads required. So we're building this completely from scratch, and hopefully you guys learn something cool out of this. So let's dive straight into it. So today our schedule is going to look a little bit like this. So first we'll create our project on Replit. We'll just create the project and do some basic setup of the canvas and the window and some variables. Next, we'll dive straight into creating game objects. That includes the bricks, the paddle, and the ball. Those are the three main game objects that we'll be creating. And then finally, we'll be doing some finishing touches, that is adding menus, adding the score, so on and so forth. And overall, this should average about to 180 lines of code. So when I said it was a lot, it's a pretty sizable chunk of code. It's not too much, but it's a pretty big chunk. So let's get started then. So first, for our setup, we want to visit Replit, repl.it. You can make an account right now to sign up or log in, and that way you can save this project for future use, or I think you can just start developing. But for me, I have an account already, so I'm just going to hop over to Replit. Let me zoom in closer for you guys. There you go. Create a new REPL, and I'm going to call this Atari Breakout. No, that's the type. Make this HTML, CSS, JS, and then here we can name it whatever we want. I'm going to name it Atari Breakout, or perhaps vhHacks Breakout, Bob Breakout. Seems the most fitting. So we create our REPL, and then we should see three things in our file system here. So we have an index.html file, a script.js file, and a style.css file. These three files are three different things that are usually used for web development. The index.html is a markup file that essentially tells us where all of our elements are going to be and everything. So that's here. Our script.js file is where all of our coding is going to happen. That's where the main game is going to happen. And lastly, style.css is generally used for aesthetics. It's used for styling your web page and whatever. We won't be using that today because we're writing a strictly JS-based game. So yeah, the only file we really need to worry about is script.js. So let's dive right into it then. So the first thing you guys want to do is load in the p5.js library. What p5 is processing. It's a very powerful JavaScript library that allows us to do a lot of really cool stuff, especially with rendering the canvases and doing all of these things. So we'll be using that today. So what we want to do is locate the header tags. Those are denoted by angle bracket head and angle closing angle bracket. In between it, we want to insert this line of code right here, which I will paste in the chat. Yeah, sure, let's format it. Let's format it nicely. There you go. So you can paste that straight in between your header tags, and this will load p5.js into our project. So let me go do that right now. So in our index, between our header tags, right underneath the link here, I will just paste in our little script tag. Save it. Make sure the quotations are working properly. So the one issue with pasting in from external text editors for some reason is that the quotations will not paste properly, so you have to go through and either change the single quotes or the double quotes back. So here you go, we pasted in our script, and now we've loaded in p5.js. So next, we're going to go straight into setting up some basic variables. So let's navigate to our script.js file, and inside we want to paste in these lines of code. Preferably type it if you have time, but pasting it in is pretty easy and it makes things a lot quicker. So if you're struggling to keep up, we'll be pasting this in. So these lines of code set up some of our variables. Window width and window height is the size of the canvas that we'll be displaying to the screen today. And the rows and the columns are going to be how many bricks we have. So we'll have 6 rows of bricks, and each row is 10 columns wide. We have our right down, left down variables. These act as our right and left inputs. We have alive, which is a variable that indicates whether or not we're alive, obviously. Constant brick width. This is a little bit of math that essentially calculates how wide each brick is going to be based on our window width, so it scales dynamically. And it gives us a 2 pixel margin on both sides because it's -4, right? And brick height is the same thing. It gives us a 10 pixel buffer, and then it cuts our window height in 3, and it essentially puts our bricks at the top third of our window. And then finally, we have 2 variables here, bricks, which is an array. An array essentially stores a collection of items. And so in this case, bricks will store the collection of all of the bricks that exist in our game. And then score, which just stores a single integer that holds all of the points that we obtain throughout the game. So let's go into our replit here, go into our script.js, and I'm simply going to copy and paste this in here. Hopefully if you had time to type it in yourself, but if you haven't, again, the code is in the chat, so go ahead and copy and paste it. I'm just going to clean that up, formatting properly. And there we go. We have all of our variables initialized. So next, let's get on to creating some objects. So stay inside of your script.js file, and now we want to create 2 JSON objects. One is the paddle, and one is the ball. So for the paddle, it'll be storing 4 variables. It'll be storing an X and a Y position, a width, and a height. And for the ball, similarly, it will be storing an X and a Y position, a speed X and a speed Y position, and then a diameter. And this just tells us how we want our game to handle these objects. So you can see in the ball's X, it requires the paddle's X and Y positions because we're going to be creating the ball directly on top of the paddle. So let's type this in here. Let me paste this into the chat. Sorry, I'm a little bit slow here. Again, you can go through and fix the spacing and the formatting. And I'll hop into REPL or Replit and do the same thing. We'll paste this right in here. So we create a JavaScript object here, and these just store different variables that we'll be using later on. Great. Next, we want to start setting up the bricks. So again, we stay in script.js, and now we want to actually create our canvas and generate the bricks that will be showing up in our game. So we first want to create a function setup. This creates the canvas for the game. We want to set the canvas to be the size of our width and height that we specified earlier. And then we want to call generate bricks, which is a function that is right below there, sitting right there, and essentially loops through all of the columns and the rows that we defined earlier, and then creates a brick at set coordinates. So again, I'll copy the code into the chat. I'm just going to paste it without formatting. It's going to look ugly. Oh, it does look ugly. That's okay. And yeah, so let's just paste that in here. So again, to walk you through the code here, the function, the setup function creates a canvas that is set to our window width and our window height, which we specified earlier as 600 by 400. And our generate bricks loops through all of the rows with this for loop here. And then it loops through all of the columns with this for loop here. And then for each of the rows and each of the columns, we create a brick that has coordinates of X, Y, and then a width and a height. And then we store all of these bricks into this brick data object. And this brick data object essentially represents one brick and is pushed or essentially stored into the bricks array that we specified earlier. So let's do this. Next, we want to actually draw these bricks to our screen. So currently we're storing the bricks, but we want to be able to see what these bricks look like, right? So for this, we want to create a function draw bricks. And this is going to go through each of our bricks here. and render it to our screen, to our canvas. And then we want to call the draw function, and the draw function is something that is natively called by p5, by pipe processing. And what it does is any code that exists within draw will be rendered to the canvas. So we'll take this. Jason, if you could helpfully format this, that would be nice. Oh, perfect. I don't even need to do that. Thank you. So we'll paste that in here. Again, ideally, we'd be typing this code ourselves. If you have the time, please do type it yourself. Getting familiar with typing code is really useful. But for the sake of time, we have tons of lines of code to go through here. So let's just try to go through all of it. So again, here, as you can see, we go through our bricks array here. We loop through each of the bricks, and then for each of the bricks, we run this little code that's nested within curly brackets, and that is to create a red rectangle at the coordinates of x, y with the width and height that we specified earlier, and then we give it no stroke so that there is no border around it. And then again, draw, natively called by p5, will essentially make our background black, and if our player is alive, it'll render all the bricks to the display. So here again, this is what I talked about earlier. If you are pasting it in, be careful about your quotation marks here, otherwise it will not compile properly. So just go ahead and replace those. And now, once all of your code is pasted in, we should be good to test it. So let me know if anybody wants me to slow down in the chat right now. In the meantime, I'm going to hop over to my Replit and hit this big green run button at the top here. And you should see all of our bricks show up at the top of the screen here. We have 10 columns and 6 rows. It has a little bit of a border on both sides, a taller margin at the top, and we have the bricks taking up 1/3 of the main canvas. We can change any of the numbers that we want, but for now, we'll just keep it at the numbers that we have currently. Cool. So now we have our bricks working. So next, we want to work on input handling. So we're going to take a quick pause from strictly making our objects, and we want to be able to take an input from our player and do something with it. So for input handling, we're going to be taking in 3 inputs. We're going to be taking in our right arrow, which is moving right, our left arrow, which is moving left, obviously, and then key code 32 corresponds to our spacebar. And essentially what the spacebar does is we'll be using it to reset our game whenever we die or if we win. So let me quickly copy this code into the chat here. So as you can see for key code right and key code left, what this does is when we press right or left, it'll just set our right down and left down inputs to true corresponding respectively. And then for key code 32, if we are not alive, it'll reset us to alive. It'll reset our paddle's X position because we know our Y position doesn't move. And it'll reset the ball to exactly where we want it to be in the original place. It'll reset our speed. It'll splice the bricks and essentially reset all of them, reset our score, and then regenerate the bricks. So there's a lot of code there that is happening, but essentially that is what it does. Let me know if you have any questions. Again, we'll just paste that right in. Clean this up a little bit. One handy thing if you want to clean up the indents, by the way, in Replit, is it's super useful in this top right corner of the code here. Auto format will automatically format all of your indents and all of your lines to be properly spaced so it looks nice. So I'm just going to click that real quick and you see all of these are consistently indented now. Perfect. So now we have our inputs handled and processed. That's great. But we want to do something with these inputs, right? Well, not quite. We're not quite done yet. We just need to add one final piece of input code, which is checking for our keys released, because we don't want to just press one of the keys and just keep moving forever. When we release the key, we also want to stop moving. That code has been pasted in the chat by Jason. Thank you very much. And yeah, we'll type that into our IDE right now. So underneath our key press, we want to add in our key released method or function. And in this key release function, again, if we press any of the keys, if it sees an action for that key, it'll reset our right and left movement. Again, auto format that, looks great. Cool. Now let's go on to creating the paddle. So the paddle will be the little bar that we see at the bottom of our screen that we use to hit the ball with. So for this one, similarly to our bricks, we want to create a draw paddle thing, and then back in our draw function, we want to draw the paddle. So this time we're going to be making a green paddle, and it'll be a rectangle at our paddles, x and y coordinates, with our paddle's width and height. Underneath it, you can see there are two if statements. The first if statement checks if we are moving to the right and we're not colliding with the wall. It'll move us 10 pixels to the right. The second if statement checks that if we're pressing our left arrow key and we're not colliding with the wall, it'll move us 10 pixels to the left. So we should have all of our movement handled with those pieces of code. Paste that in again. Again, if you're pasting it, be careful of your quotation marks. Those will have to be reset because the paste is a little bit sketchy in Replit. That's okay. Save it, format it, just make it look pretty. And then we can test it again. So go ahead now, hit run. Oh, not quite. I forgot to do that little change of the draw method that I talked about earlier. So remember here in our draw paddle, we just want to add this one line of code here that calls the draw paddle function. So if we scroll back up, find our draw. Underneath our draw bricks, we also want to now call draw paddle. Open and close parentheses, semicolon, save it. And now if we run it, we can see our green paddle shows at the bottom here. And if we use our arrow keys, we can move it left and right. Exciting, right? Whee. But that's great, but we don't have a ball. We don't have a game yet. We just have a little green bar that moves back and forth. And while it can be kind of fun, it's going to get boring real quick. So let's add the ball in. So for the ball game object, hopefully you guys can all predict now what the steps are going to be. Again, we're going to write a draw function, this time for the ball. Our ball is going to be white. It's going to be a circle at our x and y coordinates, and it's going to be passing through the diameter that we set for it. So these are all variables that we set at the very beginning, if you remember. And then circle is a function that is in p5 that allows us to just draw a circle at those coordinates. We want to leave 2 or 3 lines of space in between the line. And then at the very bottom here, we want to add ball x plus equals ball.speedx and ball y plus equals ball.speedy, which essentially constantly moves the ball in a certain direction. All right. So we'll put that into our code here. So scroll down to the very bottom, grab our draw ball function. And then our next pieces of code want to fit in right in here, right in the middle here. So now we want to add some collisions. We want to add collisions with the top and bottom edges of the screen. So we add our first if statement here, and that checks if our ball is colliding with the very top of the screen, it'll reflect the vertical speed downwards, right? And then the second if statement checks if our ball is colliding with the bottom of our screen, it's game over, we lose. So the code has been handily updated in the chat there. We can take that and paste it into our IDE here. Just to clarify, the reason why we have this here is because we want to check not where the center of the ball is drawn, but at the edge, ball.diameter divided by 2, so a radius away from the very top y. And then same here, this one we go plus because the coordinate system is going to be pointing downwards. And yeah, that's why we have this little extra bit here. Cool. Now we're going to add collisions with the left and right edges of the screen. So for this, again, if we look through our code here, this is going to be a single if statement because the behavior when it hits any of the edges of our screen is the same. It's going to just switch our horizontal direction and rebound. So in this case, and we're checking if our ball x minus half of the ball, so we hit our edge, is less than 0, so if it hits our very left edge of our screen, or it hits our very right edge of the screen, which is greater than or equal to the window width, then we just want to reverse the speed so it bounces backwards. So again, Jason has handily pasted that in the chat there. We'll put that right underneath where this other code is, right in here. Keep in mind to not copy in the top and bottom lines. Those lines are just indicating where we should put it. So you can see here we have this is grayed out and this is grayed out because we already have those in. Right? Apologies for the confusion. And now the ball should be bouncing around in our room. So if we run it, we'll see, not quite yet because we haven't called the draw ball function. But theoretically, if we threw the draw ball function in, let's just give it a test here. Draw ball. And we run it. You can see this ball spawns, it falls directly downwards, and we die. Because it doesn't collide with anything, our game is over, whatever. That's not great, right? So now we want to add an interaction between the paddle and the ball. So here, let's first add an interaction for the first half of the paddle or the left half of the paddle. And essentially what this is it'll always reflect the ball towards the left side, if you remember how breakout works. And then it'll flip the vertical velocity upwards. So here we're checking if we collide with the left half of the paddle, then we rebound it to the left and upwards. Code has been handily pasted in the chat there. And I will take that and paste that in as well. Actually, just take that. So it's a little bit messy here. We can clean these lines up. Essentially, this if statement is split between 3 lines. The first one checks if we are touching the top of the paddle. And the second one checks if we are within the bounds of the very rightmost coordinate and the middle coordinate. And if we are, then it'll run the code inside of the if statement that essentially rebounds the behavior that we just described. And next, if you want to, you can sort of work ahead here, looking at the code that we already have. How would we do that for the right side of the paddle? And essentially, it would be the same thing. So if we look at the code here, it's very similar. All we've essentially done is we're still checking colliding with the top of the paddle, but now we're also checking if we are colliding with width over 2, so the middle of the paddle now, to the right edge of the paddle, which is the paddle.width. And then you can see here, the difference between this sort of middle if statement here is now we check if the ball is already moving negative, we will flip it. But if the ball is already moving positive or already moving right, we will not touch it. So we'll let it go in the same speed that it's already going. So again, we'll take that code, plug that into our program here. And just for a little ease of viewing our code, I'm going to hit the auto format again. Cleans up all the code so things look a little bit nicer and it's a bit easier to understand. Okay. And then finally, we want to add brick and ball interactions. This is just checking each brick and seeing if it collides with the ball. And if it does collide with the ball, we're going to just be killing that brick, deleting it, and yeah. So I'm gonna, okay, it'd be helpful to format that. Essentially how this code works, if we look through it, we have this for each, which we've used previously. For this one, for each of the bricks in our brick array, we want to get the brick object and also the index that it's stored at. And we want to go through and check if the ball is colliding with that brick. If it is, we want to flip it vertically. And then we want to remove, bricks.splice essentially removes that brick with that index from this bricks array. And then we want to add 1 to our score. And then finally, if bricks.length is equal to 0, then we set alive to false. Essentially what this last line here does is it checks if we have no more bricks on the screen. Oh, thank you, Jason. If we have no more bricks on the screen, then we will just end the game essentially and go to our game over screen. So here we go. We'll copy that code now, right underneath here. Give it a handy old auto format to make it a bit nicer. And then again, we've already done this, but I went through and undid it. But you can predict what happens next. The last step we want to do is we want to go into our draw function again, which is all the way at the very top of our code now. And we just want to add in our draw ball. So scroll all the way up to our draw, which is right over here. And then type in draw ball, open close parentheses, and semicolon. Make sure if you have any color values that they have been replaced properly. Yep. And test it. So we'll give this a test now, and you can see we now have a paddle that works, a ball that moves, that rebounds off of our paddle exactly how we want it. And at this point, our game is basically done. You can also see our spacebar will reset the game properly. We are able to play, and we're able to destroy the bricks. And if you're good at this game, which I'm apparently not, you'll be able to clear the entire level. Exciting. So now let's just do a couple of finishing touches. These will be two more functions that essentially, one will display our score at the top of our screen, and then one will be our end screen message for when the game is over, and it'll essentially, it'll handle all of our game over events and our conditions. That code has been handily pasted in the chat here. So the display score, again, this is going to be a draw function, so it'll fill the color to white, align it center, and then it'll take in our score. It'll write score with a colon, and then this $ with curly braces essentially is asking JavaScript to insert a variable there, and essentially we're inserting the variable score. So one thing to keep in mind here is just be careful that these little quotation marks here are not our normal apostrophes. They're not these. They are the keys that are on the tilde. I don't know what they're called, but those ones. So if we don't use that, it'll just show the raw text, and it'll show the $ square bracket or curly bracket score. But we want to, backticks. Thank you, Jason. Yeah, so we want to put in backticks instead of our normal single quotes. So at the bottom here, we'll paste in these two. Again, we need to fix our quotation marks. These we want to replace with quotation marks as well. Here we have our backticks pasted in. Backticks paste in properly, thankfully. And now these functions are added in. Again, one last thing we want to do is just add them to our draw method. So in this case, if we're still alive, we just want to display our score on the top of the screen. So that's going to be added to the very bottom of that sort of if statement there. And then we want to add two more if statements that check our win conditions. So essentially, if we run out of bricks, so if we eliminate all the bricks, we want to call the end screen with you win. And so that will display the text you win. And then if we die and there are still bricks left over, we want to end screen with game over because we lost, essentially, right? So we'll go into our draw function here at the very top. Where is it? Here. Underneath our if alive, we just insert our display score. And then underneath this background call, we want to do if bricks.length equals 0. End screen. You win. Or whatever text you want to put in here. Length equals. And then for our second line, we want to check if we're not alive and we still have bricks remaining. So bricks length is not equals to 0. to end screen, and this time with the text game over. Save that. One last auto formatted code to make things look pretty. And finally, we can test it. So now, if we go back to our replit, I'm going to actually minimize this as much as possible so we can show our game here. Hit run. And now we can see our game works. I'm still not better at it, but it shows the score at the top of the screen here, which is why we have that slightly wider margin at the top there. Once we die, it'll say game over. Press space to restart the game, and it'll show our score. And then if we spacebar, it'll reset it. And theoretically, if I won, it would display the text "you win." But unfortunately, I don't think we're ever going to get there today. But yeah, hopefully that taught you a little bit more about p5.js. Again, it's a super powerful library. If you want to see the full documentation on p5.js, you can visit p5js.org, which provides the full documentation for it. Hopefully you learned something. Hopefully you found this fun. And if you want to take this project and add a couple of modifications and do something special with it, here's some little ideas that you can try to implement yourself to extend this project. So you can try building in some new functionality like bullets and power-ups. So essentially, in the old Atari Breakout or like block breaker games, you could have power-ups that gave you multi-ball or gave you a shield or so on and so forth. You could try implementing those. Targets and trajectory, essentially allowing the balls to rebound not just like exactly 90 degrees, but also allowing the ball to rebound like based on a certain X and Y position and giving it a bit more versatility. And then finally the magnet paddle, which is essentially adding a piece of code that allows the ball to always travel back to the paddle. And that would basically mean we have to do a little bit of trigonometry to find the exact X and Y speeds to move our ball straight back to our paddle all the time. So those are some things you can think about. But with that that's all we're going to be leaving you with today. Lastly, here are just some resources. Again, the p5.js documentation can be found on p5js.org, and we have more workshops available at vikingsdev.ca/workshops or workshops.hackclub.com. So feel free to check out any of those if you want to learn some more stuff throughout the event. And we'll also be hosting a whole bunch more workshops later in the event as well. I hope that was informational. I hope that was fun. I hope you guys all learned something. And yeah, thanks for coming. Thanks for coming out. Thanks for learning with us at vhHacks 2021. Whee.